A very good evening to all of you. Am I audible to you? Please type yes in the comment window if I am.
Yes, sir.
Okay.
Yes,
Now,
sir.
ठीक है. Switch on your camera. Second, ये ऑप्शन है ही नहीं तुम्हारे लिए. All of you have to switch on your camera. Okay. अर्पिता जी कैसी हैं आप?
सर ठीक हूँ.
थोड़ा जोर से बोलो.
सर ठीक हूँ.
वेरी गुड, वेरी गुड. सर्दियां ठीक है? पंजाब में छुट्टियां हो गई कि नहीं हो गई? 5-7 दिन की.
सर वो 9th तक ही है सिर्फ.
9 तक की है सिर्फ.
यस सर.
ओह. शानवी जी कहाँ थी आप कल?
सर वो नहीं कर पा वो मेरे कल मेरे ट्रैक की क्लास नहीं थी कल तो वेव्स की क्लास थी वो तुम
हाँ,
कर
बेस
लिया
की
ना.
क्लास थी. अच्छा.
हाँ
मैं सुना
कल
तुम
ही.
बहुत परेशान हो रही हो.
हाँ सर वो सर एक साथ इतने सारे बैचेस चल रहे हैं ऑब्जर्व करना बहुत मुश्किल हो रहा है सर समझ नहीं आ रहा
तुम
क्या
डील
करें.
देंगे. सुनो मैं तुमको बताता हूँ. देखो खत्म 4 महीने में करना है ना बेटा. अब देख 12th तो कर साथ में और ये वाला ट्रैक करती है. ठीक है. जब 12th का खत्म हो जाएगा तो फिर इसको इसको बढ़ा देना. ठीक है. मॉड्यूल वाइज
ठीक.
करना. अगला अगला आसान मॉड्यूल है थर्मोडायनेमिक्स है. ऐसा तो है नहीं तुझे कुछ नहीं आता है ना? परेशान मत
नहीं
हो.
नहीं सर ऐसा नहीं.
हाँ, अब बहुत कुछ आता है. बस तुम परेशान नहीं होना. देखो सॉल्यूशन सबका है. थोड़ा सा चैलेंज आता है. ये 1-1.5 महीना जो होता है ना, 2 महीना, जब ये बहुत सारे ये जो 6 क्लास करना, मैं मानता हूँ डिफिकल्ट है. आसान नहीं है. बट ठीक है. मतलब करना पड़ेगा ना. तुम ही देर से आई हो. मैंने थोड़ी बोला था देर से आओ.
नहीं सर.
हाँ. ठीक है. समृद्ध, हाउ आर यू? क्या हाल? समृद्ध वाघ,
Yes, sir.
क्या हाल है बेटा?
कुछ नहीं सर. कल एग्जाम हुआ 720 मार्क्स का कोचिंग क्लास.
सॉरी सॉरी, कल एग्जाम हुआ कोचिंग क्लास में?
यस सर. सेवन
ओके.
ट्वेंटी मार्क्स का.
अच्छा. ठीक है. ठीक है. अभी तो मैं क्या पूछूं, नंबर कितने आए अभी नहीं पूछूंगा. है ना? बाद में बात करेंगे अपन. ओके, गुड गुड. श्रिया, अविरूपा, ऑल वेल. प्लीज स्विच ऑन योर कैमरा किड्स.
Sir,
Lonika,
internet.
net is not good.
I keep getting disconnected.
Okay. Hi Tanushree, how are you?
Yes, sir. All fine.
All well at your place?
Yes, sir.
Good, 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 good. Naisha, good evening. Switch on your camera. Ujaswa. Chal. So we have done pseudo forces. We have done constraint relations. We have completed laws of motion technically, right? If you have any doubts, we will be doing it tomorrow. अगर laws of motion में कोई doubt है तो कल करेंगे उसको. ठीक है. आज we will be doing friction. ठीक है. फ्रिक्शन इज अ न्यू चैप्टर. दोज ऑफ यू हु
सर,
हैव. हाँ, बोलो बोलो.
सर कैन यू गिव द एल्गोरिथम फॉर सूडो फोर्स?
हाँ, कुछ है नहीं उसमें. मतलब यू हैव टू जस्ट ऐड वन न्यू. ठीक है. विच इज, you have to add one new force in the free body diagram, the magnitude of which is mass of the object observed multiplied by acceleration of the frame of reference. ठीक. Direction is exactly opposite to the direction of acceleration of frame of reference. बस ये दो चीज याद रखना बेटा. ठीक है. मैं तुमको वो माइंड मैप दिखा दूंगा. अभी 2 मिनट दो बस. तो वी विल बी स्टार्टिंग विथ फ्रिक्शन टुडे. इट्स अ वेरी इंपॉर्टेंट चैप्टर. If you don't understand the algorithm or the nature of or how to solve it, right, it becomes very difficult. So if you follow the steps which I give you, believe me, it is the most simplest of the chapters you have ever read. Okay. All types of problems in friction can be solved by using those methods, those steps. Okay. So please pay attention. Please try doing the problems. Follow the steps. That's the key to understand friction. Okay. So my first question to all of you is, give me a second. I'll just open the mind map. I'll teach you from the mind map directly. So here it is.
Yes, sir.
Okay. So what is friction? So friction is a force which opposes the relative motion or its tendency between the bodies in contact. It is also the horizontal component of reaction force. Now, how many of you understand this, that friction is a force which opposes the relative motion? Does friction oppose motion also? Tanushri, what is friction according to you?
Sir, it's just the force that opposes most of the motions.
Dekho, Abhi, you said motion, right? Samrudh, what is friction?
Sir, a force which opposes the motion.
Motion oppose karta hai. Very good. Tendency of relative motion or relative motion between the bodies. Between the bodies in contact. Now remember this. The key word here is, the key words are relative motion and tendency of relative motion. Friction never opposes the motion of an object. It always opposes the tendency of relative motion. Friction always opposes either the tendency of relative motion or relative motion between the bodies in contact. Always remember this. All of you, highlight it. मार्कर से लिखो, 4 बार लिखो, याद रहना चाहिए. Clear? So friction is a force which opposes the tendency of relative motion or relative motion between the bodies in contact. Now, it is also given as horizontal component of reaction force. Now pay attention, all of you. You will see many examples in this chapter where you will see relative motion ko oppose kar raha hai friction. Okay. I can give you one example right now. Pay attention. All of you. All of you do like this. Take your 2 fingers and try walking on your palm or on the table only. देखो टेबल को ऐसे देखो, टेबल पे अपने उंगली को ऐसे चला के देखो. All of you. And when you are doing it, observe कि how you are pushing the finger. You are trying to push the ground backwards. Yes or no? बोलो हाँ या ना? Naisha? Yes or no?
Yes, sir.
So if there is no friction between your hand and fingers, what will happen? Your fingers will slide backwards. अगर friction नहीं होगा तो क्या होगा? The fingers will slide backwards. Yes or no? So
Yes, sir.
friction is against this motion, the relative motion. So friction will always be in front in the forward direction when you are walking on the ground. Right? So always remember that friction opposes the relative motion of an object, not the friction opposes the motion of, because it is supporting you to move in the forward direction. Okay. So now we have some new student here. Take second beta. Alisa. Hi, Alisa.
Yes, sir.
Can you please switch on your camera? And I hope you are joined it from the beginning only, or you are just joined.
No, sir, I've just joined.
Okay. You know definition of friction. It's a force which opposes the tendency of relative motion or relative motion between the bodies in contact. This is what we have done. Okay.
Yes.
Now, suppose this is a block and we are magnifying the block to the extent that we are able to see the roughness at the bottom of it. So this is the roughness of the block, right? The surfaces will be irregular if it is seen under a microscope. Now this is the track or the ground and this is the rough surface of the ground. So what is happening here is there is interlocking between the irregular surfaces. Right? There is interlocking between the irregular surfaces. So friction will come because of this irregularity, interlocking of irregular surfaces. Now, one more thing happens here. There is an interatomic bond formation between the atoms of bottom layer of the block and top layer of the ground. So this bonding happens like this. Now, the second reason is interatomic bond formation between the atoms of the two surfaces, right? First one was irregular locking of irregular surfaces. And the second one is the interatomic bond formation. Now, because of this, what happens is, a force comes here, which is exerted by the ground on this block. And this force is called as reaction force. This force is called as reaction force. Clear है बेटा सबको? यहाँ तक कोई doubt है? You can ask the doubts.
Yes, sir.
No, sir.
It's just an information I am passing on, right? So this reaction force will have now two components. One is in the perpendicular direction. The other one is along this direction. Horizontal component. Okay? Horizontal and vertical component. The angle between the vertical component and reaction force is lambda, and this angle is called as angle of friction. Okay? This is normal reaction N. This is friction F. So that's why I wrote in that mind map that friction is also the component of friction is, it is also the component of the reaction force. How many of you are hearing about reaction force for the first time? Not normal reaction, reaction force. How many of you are hearing it for the first time? Reaction force. All of you are aware of it? चलो मैं मान लेता हूं सबको पता था, बहुत बढ़िया. So this is normal reaction. ठीक है बच्चों? Now comes types of friction. Types of friction. Though there are 3 types of friction, but we will be discussing only 2 types. Okay? The third we will discuss when rotational motion comes. So types of friction. First one is static friction. Static friction is a or first of all, it opposes the tendency of relative motion. Tendency of relative motion between the two bodies in contact. Okay. Second point is it is a self-adjusting force. It is a self-adjusting force. And it is given as Fs. Its value lies between Fs max and 0. The value of Fs max is proportional to normal reaction, and the proportionality constant happens to be mu s. This is Fs max, mu s n, right? This mu s is called as coefficient of static friction. All of you understood or not? Till this point, all of you understood this thing?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Now, what do you understand by tendency of relative motion? ये मुझे समझाओ सब लोग. सबने तो कहा yes sir. What is the meaning of this tendency of relative motion?
Slip होना,
Tendency. हाँ हाँ बोलो बोलो.
slip करना.
Slip करने की कोशिश करना, slip नहीं करना. It is tending to move, not moving, right?
Right.
It is tending to move. Naisha, understood?
Yes, sir.
Any doubts till this point, beta?
No, sir.
Good. So if you try to push a heavy almirah, what will happen? Will you be able to move it on one go? Tanushri, Aditya,
No, sir.
Naisha, will you be able to
No,
move it?
sir.
Lisa? No, right? It is very difficult to move a very heavy almirah. You try pushing it by applying a lighter force on it, lightly pushing it, you might not be able to move it. But you are applying some force to that heavy almirah, right? And the force which is opposing your lighter push is friction. Though the object is not moving, but there is a friction acting between the body and the floor. I hope all of you understood it. Yes or no?
Yes, sir.
Alisa, you understood or not?
Yes, sir.
Okay. Okay. So now, मुरड़ा ये इसको क्या बोलना है इसका समृद्ध समझ आ रहा है बेटा?
Yes, sir.
ठीक है. So now comes the second part of it, that is kinetic friction. Second type of friction is kinetic friction. This is easy to handle because it will come only when there is relative slipping between the two bodies, right? So it opposes the relative motion between the two bodies in contact. So wherever there is a relative motion between the two bodies, the force which is opposing each other, the force which is opposing their motion is, relative motion is kinetic friction, right? It's a fixed force. It's a constant force. Okay? And how is it given? The value of Fk is again proportional to normal reaction n, and the proportionality constant happens to be mu k. This is coefficient of kinetic friction. I hope all of you understood it. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
So let's take one example, and with this example, you will be able to understand it better. Okay, suppose this is a block. All of you, please pay attention, beta. Suppose this is a block. A force is applied here. This is the force. This force is varying like this: 0, 1, 2, 3, 4, and so on. Okay. The mass of the block is 2 kg. The coefficient of static friction is 0.2. Right? And coefficient of kinetic friction is 0.18. It's slightly lesser than that. Anybody is having any idea why it is lesser than that? Why it is less than mu s?
Sir,
हाँ बोलो बोलो.
sir, because the friction, the static friction is the friction which when the body is at rest and when it is trying to move, whereas the kinetic friction is the friction when the body is in motion, but the friction is acting on it.
But what is the change which is happening when the body is in motion and why it is lesser?
Because
So
of
because
चलो समरुद्ध तुम बताओ.
so because when the body is in motion, it will so the force required the friction may be lesser than when the body will tend to move.
नहीं
That
नहीं,
friction.
it will be lesser, but why it is lesser? मतलब वो है तो lesser, ये पक्का है. FK is less than FS max. Naisha, you have any idea about it?
because you have to break the inertia with static friction, like
Okay.
because of inertia of rest.
So breaking inertia will be lesser by this much only. Matlab, to see in this case, it is hardly 0.4 Newton difference will be there between Fs max and Fk. See, I'll tell you the correct reason. There is a bond between these two, right? There is a bond between these two when it is simply kept over each other. Now, these bonds are weaker bonds. Okay, these bonds are weaker bonds, and the interlocking is also fair good interlocking hai, theek hai, but again, when the surfaces are smoother, it is because of that. Now, when it starts moving, the grooves, jo ye interlock kar rahe the grooves, they actually break, right? And that interlocking is not as firm as it was initially when it is moving. Because it has to settle for some time, right? Then only the interlocking will be much better. The same thing happens with the bond also. तो वो जो थोड़ा सा difference है, it is because of the bonds are not able to form that rapidly when the body is moving, right? That is why there is this slight difference. So now here, the direction of friction is what? The direction of friction is backwards, and we will write the direction as the value as F. Now, what about Fs max? It is mu s times normal reaction n. All of you can see normal reaction is 2G. Yes or no? Alisa, you understood this? Normal reaction is 2G.
Yes, sir.
N minus 2G is equal to 0, so n is equal to 2G. So now, Fs max becomes 0.2 into 20. So this is 4 Newton. And what about Fk? It's mu k into normal reaction n. So this is 0.18 into 20. That is 2G. And this is 3.6 Newtons. So this is Fk. Now, all of you, just keep typing your responses in the comment sections. When applied force, this capital F is applied force, okay? Which is trying to pull this block. When its value is 0, what will be the value of friction here?
0.
Very good. It will be 0 only. Can friction be 4 Newton here when a capital F is 0? Can friction be 4 Newton when capital F is 0? All of you. This question is to all of you.
No,
Just answer it.
no.
Obviously, no. Why? Because neither there is a tendency of relative motion, nor there is relative motion. ना tendency है उसके पास, ना relative motion है उसके पास. Actual slipping भी नहीं है. Understood? Now, when you have applied a force of 1 Newton, what will be the value of friction? It will be 1 Newton. Because now the static friction has started adjusting its value, started increasing its value. When it is 2, applied force is 2, friction is 2. When applied force is 3, friction is 3. This is static friction. When applied force is 4, friction is 4. Now, when it exceeds 4, when capital F is greater than 4. What happens here is, this was till this point, it was Fs, right? So it reached a maximum value. But now what happens is when capital F exceeds 4, this Fs max reduces and it becomes Fk. Clear hai? Which is a constant force, and that is 3.6 newtons in this case. I hope all of you understood this. Yes or no?
Yes, sir.
Yes, sir.
है ना? So बाकियों को नहीं आया क्या समझ में ये? नाइशा समझ आ रहा है बेटा?
Yes, sir.
आदित्य, श्रेया, तनुश्री,
हाँ सर.
ओजस्व, अर्पिता, वशिष्ठ, अविरूपा, लोनिका, अलीसा,
यस सर.
शानवी. नहीं समझ आया बेटा?
सर आ गया.
अच्छा, तुमने नो लिखा था, क्यों?
सर नो पिछले वाले क्वेश्चन का लिखा था.
अच्छा अच्छा, मुझे लगा तुमने नहीं. कोई बात नहीं, ठीक. तो दिस इज अप्लाइड फोर्स F. दिस इज फ्रिक्शन. नहीं, सॉरी, माय बैड. On y-axis, I am writing small f, friction, and on x-axis, I am writing capital F. Now, I'll just plot this for all of you. This is origin. ठीक है? When this is 1, capital F is 1. This is 2, this is 2. When this is 3, this is 3. And when this is 4, this is 4. ठीक है? So if you plot the line here, this is how it will look like. This is how it will look like. It will follow this line. It will take a dip. And it will be horizontal then. So this is the line. यहाँ पर, these are the points which you will be looking for. This is 1, 1, 2, 2, 3, 3, and 4, 4, and then it has taken a dip. This is 3.6. This is 4. ठीक है? Copy करो, and all of you tell me what is this angle. All of you type your answers for the angle theta. This term is, sorry, ये जो है, this is Fs max. ठीक है? And this is Fk. Very good, Tanushri. Very good, Ojas. Anybody else? Angle theta. Good, Sanvi. Very good. Anybody else? Type your answers. Type
Sir,
your
I had
answers.
gotten disconnected.
You are?
श्रेया,
हाँ श्रेया, मैंने
आपने
पूछा
कुछ
बेटा ये
क्वेश्चन
एंगल क्या
पूछा
होगा?
क्या?
हाँ, ये एंगल क्या होगा पूछा है मैंने.
अच्छा.
ठीक है. गुड, वेरी गुड समृद्ध. अलीसा, व्हाट इज योर आंसर? नाइशा, आदित्य, आंसर बोलो बेटा. अविरूपा, अर्पिता, लोनिका। और ये नोट करो पूरा, ठीक है? ऑल ऑफ यू नोट इट, मेक नोट्स। Once you have noted it, please type done in the comment window, okay? And please be a bit quicker, ठीक है? So 3 of you are done. Rest of you, please be quick, be quick. Can be done. Lonika, Alisa, Shreya done. Very good. Arpita, Avirupa. अविरूपा हुआ बेटा, समझ आ रहा है?
यस सर, समझ में आ रहा है। नहीं हुआ सर, अभी थोड़ा बाकी है।
अभी नहीं हुआ? हाँ लिखो, जल्दी लिखो फटाफट। तनुश्री, अच्छा यू आर डन।
सर हो गया.
चल. So this angle is 45 degrees. Okay, because the base and height are both are same. ठीक है. So now the next question arises, how to find direction of friction. For that we will be using our mind. Okay. So we have done this static friction, kinetic friction, and rolling friction. Rolling friction appears in rotational motion, so we will discuss it there only. Now the last part is how to find direction of friction. So all of you please pay attention. These are the steps which you need to follow. First write all these 4 steps and then I'll show you how to use it. The first is separate the surfaces in which you want to see friction from each other. Okay? From each other, right? Separate the surfaces from each other. So if I have these 2 surfaces, one and the second is a block. Okay. Now, they are kept over each other. Okay. Like this. Now, if I'm pulling this block in the forward direction, and now I want to find friction between these 2 blocks. Say this is block A, this is block B. This is capital F. Okay. There is friction between A and B. And there is friction between B and the ground. Now the first step which we will follow here is separate the surfaces from each other. So let's separate it. A and B. Like this. And there is this ground also. So we'll draw the ground also. This is A, this is B. This is capital F. Now, so we have separated them. So this is the first step, right? Now in the second step, it says, observe the relative motion of each surface with respect to the surface with which it is in contact. So there is friction. Where is the friction acting? All of you, tell me in chat window type, in how many surfaces friction is acting? In chat window, tell me how many surfaces friction is acting. 1, 2, 3, 4, 5, 6, whatever. Tell me the number. Okay, Samruddh says, ठीक है, मैं तुम्हारा आंसर नहीं बोलूंगा किसी का. All of you type your numbers here. In how many surfaces friction is acting? Okay, Naisha has answered. Alisa, okay, good, good. Come on, kids, be quick. Shabash. Very good, Ojasv. Okay. So I can see that most of you have answered this. So now pay attention, all of you. Friction is acting at, देखो सबसे इंपॉर्टेंट यही होता है बेटा, फ्रिक्शन कहाँ लग रहा है, अगर ये नहीं पता है तो गड़बड़ हो जाएगी सारी. Friction is acting at bottom of A. Friction is acting at top of B. Friction is acting at bottom of B. And friction is acting at on the surface. Clear? There are 4 different surfaces on which friction is acting. All of you, if you are clear in this, type absolute clear, AC in the comment section. Very good. Shabash. Shabash. So now we want to see where is the friction acting on. So ये तो पता चल गया कि bottom में लगेगा. In which direction friction is acting on A? So pay attention to the surface with which A is in contact with. Bottom of A is in contact with top of B. So now stand on top of B and see where is this block A going. This block A will move in the forward direction because of this F force, right? So friction will act in the backward direction. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
I hope all of you understood this.
Yes, sir.
Anybody is having any doubt in understanding this? B pe, देखो, A was in contact with top of B. So stand on top of B and see where is A moving. So it is moving in the forward direction. So friction will act in the backward direction. Now, Newton's third law. Every action is an equal and opposite reaction. And it acts on the two different bodies. So the reaction force of this F1 is acting on B and it is in the forward direction. Equal and opposite. Equal and opposite in two different bodies, right? Understood? सबको समझ में आया बेटा ये?
Yes, sir.
Yes, sir.
नाइशा, अलीशा, समझ आ रहा है बेटा सबको?
Yes.
Yes, sir.
Tanushree. Okay. Now F1 is acting in the forward direction. So what about friction acting on bottom of B? Naisha, can you help me with this? What should we do here? We want to see friction acting on bottom of B. So what should we do now?
We should observe from the point of view of the ground.
Very good. So we will bring this observer on the ground. And now what we will see is where is B going because of this F1, right? So B is moving in the forward direction. So friction will act in the backward direction. Very good. So this is the direction of friction acting on the bottom of B and the ground. I hope all of you understood these 4 points, 4 steps here. How to find direction of friction. Yes or no?
Yes, sir.
Yes, sir.
Chalo.
Yes, sir.
Very good. If you have understood it, I am giving you one question to solve. There are these 3 blocks together. ठीक है, this is block A, B and C. यहाँ पे friction है mu1, यहाँ पे friction है. There is no friction between C and ground. So mu3 is 0. The force is acting on, we are applying a force on block B. Now draw the diagram like this and show the direction of friction acting on each block. But before moving ahead, tell me in how many surfaces friction is acting here. Type your answers, responses in the comment section. In how many surfaces friction is acting? In the bottommost part, there is no friction. In the bottommost, between the bottom of C and top of ground, there is no friction. Correct answer is 4. Bottom of A, top of B, bottom of B, top of C. 4 जगह लगेगा बेटा. ठीक है? Now please find the direction and please be quick. Follow the steps. Don't be quick. Do it correctly. Take your time, but follow the steps. करो. Okay. Type your answers now. Bottom of A. Type it forward or backward. Top of B, forward or backward. Bottom of B, forward or backward. Top of C, forward or backward. हाँ भाई, done.
Yes, sir.
Shabash, very good. So चलो let's do it. I'll do it on the in the whiteboard. चलो देखते हैं, ठीक है? Many of you have posted your answers. ठीक है. So this is one block. This is the middle block. And this is the third block. And of course, this is the ground. Right. So the force is acting in the forward direction on block B. There is friction between A and B, between B and C. There is no friction between C and ground. There is no friction between C and ground. So it doesn't make much sense to separate these two. So we will merge these two. Right? So now the surfaces which are free, bottom of A, top of B, bottom of B, top of C, there will be the friction acting in these surfaces, right? Now, so now I want to look into what is the direction of friction acting on bottom of A. Bottom of A is connected to top of B. So stand on top of B and see where is A going when a force F is applied on B. So where will where will A move, or where will this, with respect to this person on B, where will A move? Forward or backward?
Forward.
नहीं, इसके respect में बेटा, इसके respect.
Backward.
Backward. B is moving forward, so A will move backward. All of you understood or not? Hello.
Yes, sir.
So A is moving in the backward direction. So friction will act on A, friction will act in the forward direction. This is F1. Now equal and opposite force. Equal and opposite force on the top of B in the backward direction, right? So this is F2, sorry, F1 only. Right, bottom of B. To see the direction of friction on bottom of B, again move this object, move this observer on top of C. You can see B is moving in the forward direction because of this force, right? So friction will act in the backward direction. Okay, this is F2. This is F2 in the forward direction. I hope all of you understood this. How many of you got it correct? Bottom of B, backward, backward, top of C, forward. Very good, Tanushri. Top of B, back, bottom of B, back, C, forward. Shabash, Anvi, very good. Bottom of A, forward. Very good, Alisa. Shabash. Samrudh, forward, backward, backward, forward. Very good, Samrudh. Shanvi says A, forward. Shabash, beta. Shabash.
Sir,
Good. हाँ बोलो.
sir, can you please explain again the frictional force between A and B? That how come?
But you have written it correctly.
Sir, A
So it is right, but
forward.
I thought my logic is wrong.
What was your logic?
Sir, when the block B will move in front, then with respect to the observer, when kept on B, the block A will move backward.
Okay. So the relative motion of A with respect to B is backwards, right?
Yes.
So direction of friction will be opposing it. So that's why friction is acting in the forward direction.
Yes,
Got
sir.
it?
Yes.
Simple है, सही
Yes, sir.
लॉजिक है तेरा, गलत थोड़ी है. ठीक है?
Yes, sir.
Tanushree, very good. Alisha, good try, very good बेटा. ठीक है, all were correct. शाबाश. तो डायरेक्शन ऑफ फ्रिक्शन देखना आया सबको कि नहीं आया आज?
Yes, sir.
Good.
Yes, sir.
Now what we will be doing is, I'll give you the algorithm on how to solve problems on friction. You'll write the algorithm today. Tomorrow we will discuss, we'll use how to apply it. We will learn how to apply it tomorrow's session. So I'm giving you that. Just a second. All of you, note this algorithm. If you're done, please type done. Done, all of you?
Yes, sir.
So if you're done,
No, sir.
So I'll stop sharing it. So, any doubts in today's session? Tanushri, you understood how to find direction of friction? समझ आया बेटा, नहीं आया तनुश्री?
Yes, sir. Understood.
ओके, शानवी जी समझ आया आपको कि नहीं आया?
इससे आया।
पक्का ना? तुम आती रहो, फर्स्ट ट्रैक और सिर्फ 12th वाला इतना ही करो अभी। तुमको बहुत सारा काम है, बायो भी पढ़ना है, केमिस्ट्री भी पढ़ना है ना? टेस्ट भी लिखना है। नीट की तैयारी कर रही हो ना तुम?
हाँ।
और 12th बोर्ड भी है तुम्हारा?
हम्म।
बहुत बढ़िया, शाबाश शाबाश। ओजस्वी चंद्राकर, क्या तुम्हारा हाल है जी? ठीक है सब?
यस सर, लाइक हाँ ठीक चल रहा है।
हाँ हाँ, ठीक ही चलना चाहिए। सब 12वीं वालों की ऐसी हालत खराब है अभी, नहीं? ठीक है।
यस सर।
हाँ, समृद्ध समझ आया आज का?
Yes, sir.
वो गुड, वेरी गुड। नाइशा, अंडरस्टूड बेटा आज
Sir,
का? हाँ बोलो बोलो।
Yes.
I'm not able to access the the testing portal. How can I access it?
आईडी पासवर्ड नहीं है तुम्हारे पास? तुमको
सर
बताया तो
मिला था,
था,
पर
नाम एक
वो
साथ है। तुम्हारा नाम एक साथ है, बताया तो था उस दिन तुमको। देयर इज नो गैप इन बिटवीन।
सर पर नो सर,
अरे उस दिन तो
सर
तुमको।
had sent me a link. सर नहीं, वो लिंक ओपन किया तो फिर वो लिंक ओपन नहीं हो रहा था।
अच्छा, अभी दोबारा भेजता हूँ, बैठे रहना तुम क्लास के बाद। ठीक है, हाँ।
सर,
Yes.
मैं श्रेया
हाँ
बात कर रही हूँ।
बोलो बोलो।
मेरा 14th को टेस्ट है SHM पे।
हाँ हाँ।
तो आप उसका एक सेशन ले सकते हो क्या मेरा
नहीं
SHM के लिए?
नहीं, मेरे पास तुमको मैं एक वो दे सकता हूँ, ऑप्शन दे सकता हूँ। तुम जाओ
अच्छा,
वीडियो देखो, ठीक है?
ठीक है।
फिजिक्स प्रो गोल्ड में वीडियो है, वहां पर लीनियर एसएचएम, रोटेशनल एंगुलर एसएचएम, दोनों दोनों का है, ठीक है? देख लो।
ठीक है।
और उसके ऊपर जो डाउट आता है तुम उसके लिए मैं तुम्हारी क्लास ले सकता हूँ, क्योंकि देखो उसको पढ़ाने में मुझे 4 से 5 घंटे लगते हैं।
ओके ओके।
मैं कुछ भी पढ़ाऊंगा तो तुमको आधा अधूरा पढ़ाऊंगा, और वो मुझे खुद मजा नहीं आएगा, ठीक है?
ठीक है,
और तुमको
चलेगा।
भी ठीक नहीं लगेगा, मतलब तुमको भी लगेगा यार ठीक है हो ही गया, मतलब वो फॉर द सेक ऑफ डूइंग विल बी डूइंग इट, राइट?
ओके।
सो यू टेक योर टाइम, इट्स टुडे इज 8th। 2-3 दिन में तुम आराम से बैठ के उसके वीडियोस देख लो, ठीक है?
हम्म।
फिजिक्स प्रो लाइव 11th स्टैंडर्ड में होगा, और यहाँ पे होगा, ठीक है, कुछ वीडियो। फिजिक्स प्रो
ओके।
गोल्ड में मोस्ट ऑफ द वीडियोस होंगे। तो उसको
ठीक है।
देखने के बाद जो भी तुमको नहीं समझ में आता उसको तुम मार्क करके रखो, एंड देन वी विल डू अ सेशन, ठीक है? सो दैट विल बी अ
ओके।
प्रॉपर वे टू लर्न इट। बेटर वे,
चल।
प्रॉपर तो नहीं, प्रॉपर तो लाइव में पढ़ना, पर अभी इट विल बी अ
हम्म।
बेटर वे फॉर दिस टाइम, ठीक है?
चलेगा, थैंक यू सर।
मोस्ट वेलकम।
सर
हाँ बोलिए।
सर मुझे भी आईडी पासवर्ड चाहिए था। वो 10 से हम लोग का नीट वाला भी तो शुरू है टेस्ट था।
हाँ हाँ हाँ, नहीं मिला तुमको भी?
नहीं सर।
तुम भी रुक जाओ, अभी क्लास के बाद अभी तुमको ठीक करते हैं तुम लोगों को। 5 मिनट दो बस, इनसे बात कर लूं मैं। अभी रूपा अर्पिता समझ आया बेटा?
यस सर।
गुड। अभी रूपा, अच्छा
यस सर, समझ में आ रहा
ठीक है। अलीसा, आपको समझ में आया बेटा? यू अंडरस्टूड?
है। यस सर।
यू आर फ्रॉम
यस।
विच सिटी अलीसा?
मुंबई।
मुंबई, अच्छा। तो समझ, हिंदी आती है?
हाँ हाँ।
हाँ, समझ आया ना आज का?
यस सर।
वेरी गुड। एंड यू आर प्रिपेयरिंग फॉर विच एग्जाम, नीट और आईआईटी?
नीट। नीट।
चलो, perfect. So kids, that's all for today. You may leave the session.